Good morning, everyone. This is session 3AN on the last day of this week's sessions for GSE conference. I hope we'll see you all back again next week. This session is being given by Kim Mortensen and Gabrielle. I'm not even going to try, from BMC. And they're going to talk to you about streamlining your batch to use less time and CPU. Please remember to give your feedback at the end of the session. And if you have any questions during the presentation, if you can put them in the chat, and then the guys will address those at the end. Okay, so the other thing for this year is the charities. We ask you to donate generously. It's also a way into the raffle. So for every £1 that you donate to the Royal National Lifeboat Institution or Guide Dogs for the Blind, you can get a raffle ticket to enter into the GSE raffle. Okay, but yes, please give generously and show your appreciation in that way for the kind attention of the presenters and the session content, which, you know, doesn't appear out of nowhere. So please show your appreciation for their hard work by donating generously. At this point, I will hand you over to Kim and Gabrielle to provide you with useful knowledge. Thank you.
Thank you, Anna. And I hope we can live up to that last sentence, that we can provide you in this session with some useful knowledge. And I want to welcome you all to this session about streamlining your batch to use less time and CPU. My name is Kim Mortensen, and I will be joined by Gabriel today in this session. The agenda we have here, we will do a short introduction. We will talk about the challenges with the mainframe batch, and then we'll do some discussion on what if scenarios. So questions is what if something like this and this and this, and then try to have a good discussion about that, and then try to come back with some answers to those questions. But let's introduce ourselves shortly so you know who is doing the presentation today. And Gabriel, will you introduce yourself?
Yes, so welcome as well from my part. Thank you, Kim. And so my name is Gabriel Gut-Kalschmidt, and I live in the Netherlands. 1998, I had my first contact with mainframe batch jobs. And this was when I started as a junior system controller at Atraxis. This was the IT company of the former Swissair, if someone remembers this airline. And since then, I'm working on the mainframe in different roles. So I joined Compure and now BMC 1st May last year. And the last role I had on the customer side was performance manager at the second largest bank in Switzerland.
Okay, thank you, Gabriel. And for me, my name is Kim Mortensen. I'm based in Denmark. And I started out in IT back in 1986. So just a short story about that time frame. That is where kicks were getting hot in Denmark, so CICS. But batch was still run by hand. And I remember when starting as a developer, you know, the schedule was really on paper, and it was delivered to operations by the operation manager, and it was ticked off on those paper sheets. So a lot of things happened since then, and what we're going to talk about today. I also worked with BMC and come from CompuWare, so part of the BMC acquisition of CompuWare, and I'm working on our performance team where we support EMEA. So with the introductions done, let's move on to some of the challenges that we see and there is in the mainframe batch. So Gabriel, I think that you have a few things you want to share.
Yeah, so thank you, Kim. Yeah, in my life on the customer side, on the mainframe, I was as well batch controller, and I want to share this experience with you, and I'm sure you will find yourself in similar situations. So back in time when I was a batch controller, I had no idea about the impact we did on the system with the batch processing. We had SLAs to meet, and therefore we did a lot. We changed service classes of individual jobs to increase the performance. At least we thought so. So we pushed the critical path manually very hard to reach the end job before SLAs. And of course, we didn't have only one job running during the nighttime processing. We had up to 150,000 jobs were running on a normal day. And on special processing days, such as month end, quarter or year end, we had even more jobs with even more input data running. So it was very impressive and very stressful at this moment in time. And then, of course, if all goes well, it's happy and we will reach our SLAs. But if an event occurred, first we had to reach the responsible person, and then they had to fix the error, and we had to rerun the job. And on unlucky days, we missed the SLAs, and the day-end processing was running into the online day. And of course, I heard about the online running during daytime at this point in time when I was a batch controller, but the team was focused to finish the batch processing. In this stage, I was not aware of capping or limited resources to control the mainframe costs. All challenges on these pictures are somehow connected with each other, and I'm sure there are much more challenges related to batch. So the challenges we saw before can be grouped. Batch window, critical path, online availability, there becomes SLA. And then manual intervention built its own group because I think it's an important group. Then we have bulk scheduling and high number of batch jobs, and they goes into over-initiation. And we will talk about this in this presentation as well. And then we have month end, quarter end, year end, and they become high data volume. And of course, a very important point, capacity and capping builds cost control. And no matter which of the group is at the center, they are all interconnected. They are all playing together. And in different times, the priorities can be different. So cost control can be on the right or the left corner, and something else could be then in the center. But all of these challenges will be there anyway. Now, let's have a look how we think these groups impacts the mainframe processing. So cost control, of course, it's an important topic. And by introducing cost control, such as capping, the capacity available can be reduced dramatically. In general, with rolling 4-hour average, if the capping limit is not reached, much more capacity is available. But by hitting the cap, the capacity will be reduced to its defined maximum. At this moment, too much work is on the system. The work unit queues increases and the overhead increases on system and as well on task level. The system gets busy to manage the queues, and the tasks use more CPU cycle to finish their work. The elapsed time increases. And then the SLAs, of course, for the business, this is critical. To meet the SLAs becomes a challenge if the batch window gets shorter. And the CPU resources are short because of cost control and errors occurring during the batch processing. In all these cases, the intention is to push batch to finish the SLAs defined. And by increasing the service classes assigned to batch, it gets more resources. At least we thought so at this point in time. And if the priority is set high enough, we can compromise or even overtake priority of a subsystem. And if the SLAs cannot be fulfilled, often the online processing gets affected. Before I mentioned manual intervention built its own group. And this manual intervention are risky for several reasons. On one hand, humans are not able to analyze a system in real time and then treat batch jobs with the commands according to the system status in this point in time. You will see as well an indication of something happening, but it's all time behind what the system does. And on the other hand, it's a human characteristics that error can happen. And if they happen accidentally, this can have significant consequences for production environment. Over-initiation. So this term describes the circumstance that too many jobs are to be executed at once in relation to the CPU cycles available. Sounds complicated, but isn't. So this leads to overhead at the system and task level, and also increase the average elapsed time of the batch jobs. And then the last group we built before, the high data volume. Of course, high data volume can be a sign of business workload, and this sounds very good. But to process an increased amount of data, you need more CPU resources. So your batch window will be longer as usual. And if possible, you will try to run such batches on weekends. But if they must run during the week, you have to protect your online workload the next working day. Let's summarize the impacts of batch processing on the mainframe. So it's not batch processing that affects the mainframe, but how the batch is processed. By creating overhead with batch, the costs per job and overall increases. Overhead on the system increases the job elapsed time. The online availability increases, the batch window gets shorter. And of course, the complexity of batch processing increases as well. So.
Yeah, I think that was really enlightening, Gabriel, and I think that it hits the nail on the head about the challenges we face today with the mainframe batch workload. It's not really the batch workload itself, but it's the way we manage it. So given the challenges that we just talked about, I would like to focus on some questions that we are facing when working with companies regarding batch workload management. And I, of course, hope you can help me answer some of those questions. So, you know, with this slide, in a fairy tale, you might be granted one wish, but I think that today we might go into get into a situation where you can get multiple wishes granted. So with that, just to repeat myself, I think it was great hearing you telling about the challenges that you have as a batch controller and a performance manager. Real world examples are always good stories to hear. So you talked about over-initiation and work queue buildup. You kind of put an emphasis on that is important on the batch workload. So my first question to you would be, when I submit a batch job, it will go into the execution queue and start execution right away. Am I right?
Yeah, Kim. So I think this is a very good question, and this is what all others assume as well. So when I submit something to the system, it has to be processed immediately, and I think it will be a good idea to talk about what happened to a job when it gets submitted. But before I get more specific about your question, I think we should have a look into the job execution, what happens there.
Okay, yeah, that'd be cool. That'd be cool.
So we will talk about the JS2 batch workflow. And I do not want to explain all points, but we should talk about two very important points in the workflow. And these 2 points explains why often batch workload brings the system into trouble. And do you see where the way splits into JS2 and WLM?
Yeah, I see it.
Okay, so of course, JS2 and WLM, no doubt, they are both great inventions, and yeah, without them, mainframe wouldn't be what it is today. But both of them have a weak point when it comes to initiation handling. So initiator handling. So JS2 initiators, I don't know if you know that already, but I will tell you what happened with the JS2 initiators. And they are started, the number of JS2 initiators are started when the system comes up. They are defined in the JS2 definitions. And to change the number of JS2 initiator, you have to do it even in this definitions of JS2 or manually afterwards. But this is a static number of JS initiators. So you have too much JS initiators defined or too less. But for all the different situations on the system, the number will never fit the situation on the system. So this is the weak point on the JS2 initiators. And then, of course, this is one of the reasons why IBM invented WLM. So WLM initiators are very focused on the performance goals relative to the importance of the batch workload and the capacity on the system. And it's really good thing that these initiators or WLM is doing. But there is as well a weak point, because WLM stops to or decreases or start to balancing, to be precise on this, starts to balancing the system only when the system got 95% busy. And this often leads to over initiation. So we have too much workload on the system for the capacity available. And this is a weak point of WLM, and these 2 points brings often the system in trouble. So Kim, as you can see, quite a lot of work is performed from the time you submit to it end up in execution. But you ask, when I submit a job, it will go into execution right away. Is this correct?
Yeah, I think that, yeah, that was my question.
Okay. So when we think back on the flow we just did, so there is nothing there except the number of available initiators that will prevent you from going into execution if your JSL is correct. So you are right. Your job will go into execution if there are initiators available and your JSL, you did your JSL right. But if there are too many other jobs, this can cause a problem, because you will be then at the end of the queue and you will wait then until you get your slot on the system. And when you get into the system, you suddenly, the data set you need is held exclusively by another job. And when a data set or resource is not available to the job, it will sit in the execution queue and wait for this resource to be available. And at this point, the initiator has already picked up the job and created the environment for the job to run in. That means it has been going through JS initialization, WLM categorization, and the job has already consumed some CPU and allocated resources like storage and DASD. But it's still not running. It's waiting, and the system must spend resource keeping an eye on the job so that when the resources gets available, it might be able to grab it and get into execution again. And this situation creates or will create overhead. The efficiency of this batch job will get poor as long as it takes, and it can lead to a high work unit queue if you have more of this kind of jobs.
Right. So my system will benefit from jobs being able to execute right away and not sit in the queue waiting on resources.
Yes, you're absolutely correct. So this is one of the additional areas where JS2 has a limitation, and how to select work and to interact with other components in the ZOS system.
Okay, so talking about that and talking about the work queue build up and job should be ready to execute when it gets into execution, you know, but in my head, I said that having a lot of workload ready will enable me to use my investment in hardware 100%. So, you know, I have bought my machine, it is down in the basement, I have my workload, I want to throw everything at it and let it run 100%. But is that okay?
Well, from that perspective, you would be right. Of course, you want to use your machine and drive your hardware to the maximum, to the 100%. But it comes with a cost. When driving your workload to your LPOS or machine higher than 75 to 80%, you will start to have a bigger overhead and a waste of CPU cycles that will drive up your CPU consumption and costs. And both Gary King and Gerald Watson stated that when you go up 10%, your overhead will go up by 5 to 8%. So that means more CPU cycles will be used per instruction, and more CPU cycles will go into managing the workload. And what you should do is managing your workload and set some thresholds that would make sure you run your machine as efficient as possible, and not the 100% will not be the efficient as possible. Mm-hmm. And the idea would be to run your batch workload hard, as efficient as possible, and to pay attention your MVS busy and your onlines. And remember that onlines a few years ago they ran between 7 o'clock in the morning and 6 o'clock in the evening. But now nowadays onlines are 24/7. So you want to pay attention to your onlines when your batch is running, and you don't want to run your batch workload into the daytime and by take away too many resources so that your onlines are suffering and your customers cannot do business with you.
Okay, understandable.
And it's all about running the perfect mix of workloads and making sure that when your jobs are getting into execution, they run at machine speed. And the fastest possible way to lower CPU consumption and shorten your elapsed times, effectively improving your critical path for batch workload and provide your business with the resources it needs at any given time. In many cases, you will see operators trying to juggle the resources available and turn the handles that they know. I did the same thing. So, but imagine you have 150,000 jobs during your 6 to 8 hours batch window. That is 300 or more jobs a minute. That's not easy for a human to do that.
No, that is really a high number. So So what you're saying is that I need to pay attention to how high I actually drive or let my workload drive up the machine. So I do not get into a situation where I start losing CPU cycles to do the same work, doing job A and B. And basically, if I drive it too high, if I drive machine too hard, I can basically see that my A and B will consume more CPU cycles for doing the same work. But at the same time, I need to pay attention to, if I go into my online day, that I can take away the resources that should actually drive my business.
Yeah, that would be the perfect scenario. And as we talked about a moment ago, so this is nothing that operators can monitor. So to be honest, with the increase of the complexity and the workload and all these things, it's very difficult for an operator to follow all these things at the same time.
Yeah, I think things have changed from the day where you had the schedule on paper, like when I started my days as a developer.
Yeah, definitely.
But talking about schedulers, so nowadays Batch is run by a scheduler, and almost everything we saw, almost everything as we saw earlier, your slide where you showed the process of a job coming into Jess and how it's processed. We saw that you can come from a scheduler, but you can come from TSO, you can come from Kix, everything that can actually drive some JCL into a system. And in a production environment, the scheduler is probably the main vehicle to drive execution of the batch workload during, for example, the end of day processing that we talked about. But before submitting a job, the scheduler has been fed with some information about the jobs and the dependencies between them. So what I think is agreed to call the plan. So A runs before B runs before C, D, E, and F, and so on and so forth. And having that plan, the scheduler submits the jobs according to that plan and updates the database with information about when the job was submitted, when the job ended, the elapsed time of the job, the CPU times, and so on and so forth. So the schedulers are getting, going from the paper version I talked about to the modern schedulers is like having a database with information around the job and the execution of the job. But when a job is once submitted, the scheduler has no idea what will happen to the job. Now, as I see it, it leaves it up to the system or WLM to manage it. It's basically submitting it and don't just, throw it in there and let's see what happens. So I think that sometimes it would be handy if we were able to add more information about a job, to be used in the system when it gets submitted. So for me, it seems like when submitting something, it's like a black box.
Yeah, so you're right. Of course, actually, if you submit a job, you do not know what the system does in behind the curtain. So, but I can tell you some metadata are already in place. So like job class, service class, job priority, and all these are fixed in the definition of the JCL and used in the classification by WLM to assign a service class to the job. But it would be great if you had the possibility to take your job and then add attributes, so metadata, that would describe the business importance to make the system able to run jobs based on their business importance instead of their classification. Mm-hmm. And jobs can have the same classification, but different business importance. Does this make sense?
Yeah, I think so. So.
Okay. Most in mainframe jobs, if not all, they would have a schedule in place to drive the batch workload. And a modern scheduler absorbs and collects a lot of information on every execution of a job. And it would be very cool if a scheduler would be able to feed then this knowledge it gathers. For example, information about due in, average elapsed time, or all the things a job does in the system to the system, and that could allow the system to manage the job according to that information. So to see if they are already late or early or from the time when they arrive in the execution and when they are expected to finish to make the SLA. So we talked about the SLA for the business is crucial. And that would allow for making sure that the job that needs an extra boost, like a better service class, you get and make its SLAs close.
Yeah, I think that would definitely make a difference. I think that today's scheduling managers and those who are responsible for the schedule plan all jobs on dependencies, critical path, and SLAs, and so on and so forth. But one of the biggest problem is that they cannot influence the execution of the job that is out of their hands.
And this will be something that every shop would want to implement. So taking manual checks or pseudo jobs out of the schedule and let the additional metadata and add some additional intelligence on top of the job execution.
Mm-hmm. Oh, wow. All right, yeah. So moving on, some of the things that we also talk about is the manual intervention. So we talked in the last slides about how cool it could be to have some additional metadata to a job to help it in the execution phase. But currently we see a lot of manual intervention by operators trying to manage batch workloads and to make SLAs, and we also see that different shops are using system automation to kind of react to commands with when they see certain messages in the system. That is quite a responsibility to put on shoulders of operators and system automation. Yeah,
so I agree. When setting up a plan for the scheduler, it's all about being able to execute jobs in the correct order and try to keep the critical path as visible as possible. And we are seeing different ways of informing operators on the progress of the current day's workload. But having maybe 100,000 to 150,000 jobs to monitor will make this very difficult, so to be honest. And we see that pseudo jobs are implemented to highlight where the critical path we are and if we are on time. But how do you differentiate between good and bad information? So is that bad if you are 10 seconds late, or is it 10 minutes? And what will be the impact of changing the job class, the priority or the service class of a job? Will you impact other important workloads currently running on the system by making it less important from a system point of view? And if yes, by how much? And would it be preferable to have a way to specify how your workload should be treated independent where it comes from? So jobs might come from the scheduler, you are totally right. But it could be as well, I submit a job via TSO, and this could be a not very important job, but it could be as well a very important job. So as we talked about, scheduler should be able to add additional metadata based on the history of the batch job. Or we should be able to give it an importance that would allow operators to trust the system. And we have worked with several customers where we do run our analysis of the syslog, and we see how operators and system automation tools try to help, and I say help in quotes, one or more jobs to execute better, but it's not paying attention to the overall picture and the workload. And when you give more resources to a job or bring additional jobs into execution, you might start over-initiating or bringing your system into a high MVS busy situation. And that might not be what you want. So remember, we talked about when you ask about running at machine speed, there's a bigger chance that you will hurt the system. Okay. And we have seen that customers have been using SDSF A block commands to release 10, 20, or even 100 jobs without thinking about how that would impact the system. And we need to get more balanced approach to this.
Yeah, understood. If I was trying to juggle and understand the full picture of the overnight batch, I think that I would have liked someone or something that would make sure that jobs only run to the best of their abilities. Yeah.
Yeah.
I think that's important. Yeah.
Would it not be great to free up the operations resources to focus on the real problem and not try to juggle these resources, as you already told? So make your workload run at its best.
Yeah, well, I totally agree. I totally agree. So one of the things that happened with also in the batch workload space is that with the release of the C15, IBM introduced a recovery boost, where you free of charge would get some additional horsepower to support your IPL or shutdown process. And also, if you have to do an emergency recovery, that is not that often, but it is there. The idea is that, even if you are running a sub-capacity model machine, you'll be able to run the GPs at full speed during the boost. And if you have SIPs, you will also be able to utilize those engines to speed up your recovery process. How could we take advantage of that new feature?
Yeah, so in this situation where you must prepare for an IPL, the shutdown process, most jobs have a procedure in place that would prevent the scheduler to start more jobs and start training initiators, canceling jobs, etc. So with the new C15, you will have a period where the machine would fire on all cylinders. And you can take advantage of that. That would allow you to prioritize which job you want to finish and which jobs you do not want to bring into execution, even though we get the boost. The same thing happens when you do an IPL. You will get a boost for a given period. And here also you want to make sure that important workload is being prioritized and helped by the boost. As with the shutdown, a defined process is in place to start address spaces in the correct order and to make sure we catch up on where we left off.
All right.
And both shutdown and IPL, most jobs would ask the scheduler to stop submitting jobs, or they have stop jobs in place where the right to operator would allow them to not execute any more jobs. So, but imagine that you would be able to specify if batch workload should be able to start during the shutdown or IPL boost. And if you could control which workload based on its business importance. Think of the case where a scheduled IPL occurs, but it takes longer than usually. So you need to make sure that your most important workload starts executing and want to hold back the less important. And is that a manual process based on the job name sitting in the queue, or service classes currently assigned to the jobs? We talked about before, so this probably are not the critical jobs for your business. So.
Yeah, so it sounds that you really have thought about it and how you could take advantage of the system recovery boost. Yeah. Oh,
yes, great. I think that the most installations have already begun to think about this and how they can utilize the system recovery boost, but be able to automate the selection process by importance. You do not think that anyone has the ability to do it yet, but
yeah, let's see. So Gabriel, we have a lot of challenges, a lot of good questions, and a lot of challenges that needs to be faced at some point. If we were to fix this and we could streamline our batch more to use less CPU and has shorter elapsed times, I think that the challenges needs to be addressed for us to take back and automate maybe 90%, 97% plus of the workload being processed. So as we speak, do we have a solution? Do you have a solution for me that would help me with the challenges we have talked about?
So Kim, you are so lucky. And of course, I have a solution for you.
Oh, wow.
So the firework is not a solution, but it is nice pictures.
Okay, all right.
So we have a solution and it's called BMC CompuR's Throughput Manager. And Throughput Manager is a solution that focused on batch workload management.
Mm-hmm.
And it will add itself to the lifetime of a batch workload and will address all the challenges we have talked about, all. But it's not all about batch workload. When you can manage your batch workload, you will impact all the other address spaces running on your LPAS and machine. So we also talked about batch running into the online day or the online becoming 24/7. Throughput Manager is able to keep an eye on the PIs of your online workload. As soon the threshold set is reached, Throughput Manager will start to defer batch workload, of course, according to its business importance.
Mm-hmm. All right.
Let me start with how Throughput Manager put herself. This is honored to our former colleague, Brenda Taube. Let me start with how Throughput Manager put herself into the process when you submit a job.
All right, let's have a look at it.
So,
okay. So, are you going to show the whole process, or you are taking it step by step?
I think I will do it step by step. It's
right.
easier
Okay.
to.
Let's go then.
Yeah, it's easier to explain step by step.
Okay.
So we have the analysis phase. Throughput Manager will, in this analysis phase, build a number of variables based on the JCL and input from the scheduler. And that can be used to manage the batch workload.
All right.
And then on the second stage, Throughput Manager queue. So a new construct that allows Throughput Manager to set up a queue to manage job coming, not the system,
Mm-hmm.
but will sit on this queue until it can execute.
Right.
And then we have the Throughput Manager job selection. Here, Throughput Manager selects the jobs for execution and make Throughput Manager initiator available to it, either using an initiator or starting a new initiator if needed.
Mm-hmm.
And then on the next, Throughput Manager will manage the execution. It will keep an eye on the workload and it's being submitted. So is it running okay, or does it need more juice? Machine is running at too high percentage, so we need to throttle a little back on batch workload.
All right.
And all of this managed to the goals and constraints that you have defined within Throughput Manager policy. That is the mechanism you use to define how to run your batch workload.
All right. So it seems that adding Throughput Manager makes it that, will it make the process even more complex? There's a lot of moving parts there. Maybe not really. Well, you know, I think that the idea with Throughput Manager, even though you see a lot of boxes, is that, you know, it is going to be under the covers and kind of lead into a more simplified but more, you know, smooth solution that will help you not to do all the manual stuff, but go more into automation. So going back to my two first questions, we seem to have a solution to the first two challenges, is where how I make sure that my job is ready to execute when it goes, when I submit it and it goes into execution, and how to run at machine speed.
Yes, so Throughput Manager will hold back your job until all resources it needs are available for the job to execute. And the way Drupal Manager does this is to manage a single queue with all the jobs that wants to go into execution. At the same time, Drupal Manager will manage the initiators to make sure we do not over-initiate. So it makes no sense to bring jobs into execution if the system is already overloaded. Mm-hmm. But let me go a little bit deeper on the next slide on this. So on this slide, I will show you a few of the benefits that a single queue provides to the system. So the jobs are prioritized by their business importance. And the big difference to JS2 is the time spent on the queue. It will make the job more important. And the concept of time is not part of JS2 today. And so you could sit in JS2 queue identically and never be important enough to get into execution. And with Drupal Manager, time will be part of the evaluation of your importance and place into the queue. And you will get more important as time goes. And the queue is reordered every 10 seconds. So the time spent on the queue will be used for job setup and to make sure the job has the resources it needs to go from the queue into execution. And this will make sure that when the job becomes the first in the queue, it will be ready to execute at the most important job to execute given the business importance. And let's explain this with an example. Imagine you take a taxi to the airport. You're perfectly in time. Then short before you arrive at the airport, the taxi gets a flat tire. And your taxi driver did a great job. He fixed the problem with a spare tire. But then you see that you lost time and now you're almost late to catch your plane with the security checks and all other checks you have to do. But wouldn't it be great that an airport manager would help you to get in front of the queue? On the queue actually are people that still have 2 hours left to catch their plane, and yours is closing the doors in 30 minutes. So it will make sense to have you moved to position 1, otherwise you will miss the plane. And as mentioned on the what if slide, Drupal Manager is also managing the initiators for the workload. By having the control over initiation, it is possible for Drupal Manager to have only the needed initiators ready to run the workload. Mm-hmm. And Drupal Manager, it monitors all the time the overall system performance and workload to identify the right number of initiators. Taking about initiation, it comes to mind that our friend Kelly Focht, he will talk about the importance of proper initiation in his session, the 11th of November. So I'll look in this session as well. Initiator management. So specify the result you want and the policy does the work. Drupal Manager automates start and stop of initiation, ends over initiation and under initiation based on supply of CPU and workload demand, and not simply the number of initiators. Optimal system loading and balance for increased throughput. Constantly adjust based on workload performance, and all works will run at machine speed.
All righty. Okay, that sounds like we have something there that will be definitely good. So, we also talked about the to use job statistics to aid the execution of a job.
Yes. So an integration can come in many flavors. And regarding integration between Drupal Manager and Scheduler, we have chosen a simple but very efficient approach. And the integration is done by JCL comment statement that are injected by the scheduler at the time the jobs get submitted. This approach opens up to build integration to all schedulers that want to play with us. And of course, the main integration is with Control M and HCL. Workload automation. But other schedulers could be easily targeted with this process. Oh, let's look to an example of this.
Yeah, sounds good. So yeah, here you see an example of that, on the left-hand side, Control M, and with the comment card. So, how the product itself, when you set up the system for actually doing this, can, inject the JShell statements that will be consumed by Drupal Manager and used for managing the queue. So when you're in early, you can sit in the queue a little bit longer, as Gabriel explained you with the taxi driver analogy, and when you arrive at the airport. But if you're a bit late, we can see that on the information that is brought into the system, and we can actually use that to make sure that you get ahead of the queue. So you get in front of, maybe not to the top, but close to the top. So you are almost the most important job to run the next time a job needs to be picked off that queue. I don't want to go into the details, but you can see here how you set it up, and you always that is so cool. Some of the things that we also do is that the information we put into the comment card is also made available to both Drupal Manager and to what is called JAL. JAL is an action language that allows you to actually work with this information under the covers of Drupal Manager and extend the policy that you have within Drupal Manager. So I think that's really it about that. So we talked about recovery boost earlier, and you mentioned that it would be great to have more granular control over the different boost periods. So I imagine that you will now tell me that Drupal Manager is helping you to get that as well.
Yes, of course. So yes, Drupal Manager is recovery boost aware. And we will allow you to set constraints on the way Drupal Manager takes advantage of the boost, but at the same time, make sure that when you take advantage of the boost, that you do not get into an overload condition where the boost period is over. And for all three types of boost, Drupal Manager will allow you to specify. When not to select any jobs, when the boost approach its end, you choose not to select any new jobs for execution. And you select specific jobs, quick jobs, jobs with an importance that are greater than certain thresholds. This will allow you to select and run the most important jobs without bringing too many jobs into execution. And when the boost periods end, you have too many jobs in the execution when your resources are being reset to your normal setup.
I think that is a great way to take advantage of the boost period, where you get additional resources without putting yourself into a difficult situation when the boost ends. I think that, adding this will really help all mainframe customers, and I think it's a great new C15 feature.
Yeah, I totally agree. So this is the best of two worlds.
Yeah, I totally agree. So, Gabriel, when talking about a C15 and all that, something we didn't really got kind of a what if question challenge on is that I heard with C15 there's now different billing models, and there's now the new tailor-fit pricing and tailor-fit hardware pricing. Do you have a solution to run batch in this billing model as well?
Kim, I see you are up to date. Yes, Drupal Manager supports tailor-fit pricing as well. So for tailor-fit pricing software, the maximum consumption is limited by the purchase capacity. And this leads to less delays and shorter elapsed times. But high CPC utilization leads to higher overhead. With the same mechanism we already talked about, Drupal Manager will or is able to handle batch in tailor-fit pricing. And one specific thing to mention is from C15 on, chargeable tailor-fit pricing hardware option can be added, the tailor-fit pricing corridor. And I don't want to go into details at this point, but the goal of this option is to have capacity available in case of workload peaks. And in this case, you will pay for the usage of this tailored fit pricing corridor, and therefore it makes sense to use it only for high importance workload. And Throughput Manager recognizes the usage of this tailored fit pricing corridor and prevent that low important batch will use this capacity. Does this make sense?
Well, definitely. I think that, you know, I can have spare resources that I can utilize if needed, but I want to use it to boost my most important workload, you know, not wasting it on just running workload that is not important for me. So definitely it makes a lot of sense.
Yeah. So what do you think, due to the time we are now, makes it sense to have a look into the questions?
Yeah, I think so. Yeah, I think so. That'll be good. I think that we came around with a number of challenges. We addressed the challenges. We showed you how you can overcome them, and we discussed them in more or less details depending on the topic. So yeah, let's see if there's any questions. And I see one here. Does JES3 work in the same way? Oh, so that could have been asked, or it has been asked earlier in the presentation. So at least the discussion we're having about challenges, I would imagine that from my perspective, the job entry system of JES3 will have the same challenges on how, you know, to work and how to manage your batch workload. If that is the question, I think that it doesn't matter whether or not you are a JES2 or JES3 instance. It's more about the challenges you're facing. How can you cope with those? How can you find a way to, you know, streamline your batch better, take advantage of what hardware you got, run it at its optimal capacity, and with the addition with Throughput Manager, you can basically run it a little bit better and more automated because it looks at all the parameters at when it actually runs, so at all the time, whereas a human will have to, you know, take a lot of info and trying to figure out what to do, and basically will always be late. JES3 is not supported in the way Throughput Manager is today, but Throughput Manager actually understands the JES3 constructs and can help you convert from JES3 to JES2. If that answers the question. Otherwise, please be more specific in the chat. I do not see any more questions. So,
I have set it so you may unmute yourselves if you would like to directly ask a question to Kim or Gabriel. You are capable of doing that now. The mute button is in the lower left corner of the screen.
It's quiet.
Hopefully that implies that there's no question and they're not sleeping. You know?
Yeah.
Okay. So the presentation is actually complete now. I can leave the window open for a little while if you do want to chat either to each other, those of you that are in the call, or with Kim and Gabriel. And please remember to submit your session feedback. This is session 3AN. You can do it either using the QA code or put 3AN at the end of the web link. Also, please, one of the questions is about the length of the presentation. 9 is not a good answer, said it was too long. It's a different numbering response for that question. So 5 is the perfect score. So bear that in mind when you're doing your feedback, and hopefully see you at the next session too. I'll leave the session open for a couple of minutes just to see if anybody wants to chat. After that, if no one is chatting, or if everybody's left the session, which you can of course do, then I will end the whole session. Thank you. Thank you very much. Thank you to Kim and Gabriel. I lead the round of applause.
Thank you very much. Thank you for having us.
I never worked out quite how to use that button to make a clap come up on the screen. So you get the real thing. And again, everybody, if you can show your appreciation for the time and effort of our presenters by making a generous charity donation, that's appreciated. Thank you very much.
Thank you, Anna.
Thank you.
Somebody knows how to do the clap. I just saw it.
Thank you very much. Thank you, and thank you for attending on the call.
Okay, there's just one person left now.
All right.
So, and he hasn't unmuted, so I'm going to assume that he's not ready to chat. So
No. Okay.
Okay.
Okay, I shall end the session now.
Okay. Thank you very much,
enjoy
Anna.
the rest of GSE.
Yeah. Thank you. You too.
You're welcome. See you again.
See you. Thank you.
Bye.
Bye-bye.